Hello, welcome to my channel. Today I want to talk about the cerebellum and its pathways. So there are two other videos about the cerebellum, the layers according to the cortex cerebellum, and also the anatomy and also functional anatomy and nucleuses of the cerebellum, which I have recorded before. I highly recommend you watch them and then come to this video for the pathways. Well, as you see, this picture is a little complicated, but step by step, we will go and it will be easy for you. First of all, I want to tell you what is this. This is the superior cerebellar peduncle, middle cerebellar peduncle, inferior cerebellar peduncle, the vestibular nucleus, the superior, lateral, medial, inferior part, the inferior olives, the spinal cord, the cross section of the spinal cord, the cerebellum itself, Purkinje fibers, which are in the Purkinje layer of the cerebellar cortex, the dentate nucleus, which the sentence which we wanted to memorize: don't eat greasy food, don't dentate, eat emboliform, globus, greasy, and food, fastigial nucleus. So anyway, in here, please pay attention: the red nucleus, the reticular nucleus, the pontine nucleus, the cerebrum, the basal ganglia, and also the sixth cranial nerve nucleus, the fourth and the third cranial nerve, which they have relation with the vestibular nucleus, and also the cerebellum, which I will talk about it. So how I will start talking about this, I'm going to talk about each kind of peduncle: the superior cerebellar peduncle, middle, and inferior. And for each cerebellar peduncle, I'm going to talk about the efferent and afferent fibers, and that is how we are planning to go forward. So for the superior cerebellar peduncle, what are the fibers which go inside? What are the fibers which go outside? Of course, there are more than this list fibers, but in this video, I'm going to concentrate on the most important fibers that we must know. So superior cerebellar peduncles, it has efferent fibers and also afferent fibers. Efferent means it will go out of the cerebellum, from cerebellum to other parts. Afferent means it will receive the information, it will receive these fibers. It means they will come inside. So let's go forward. The efferent fibers, one of them is dentothalamic pathway. Dentothalamic pathway. What I mean? Look at here. Dentate nucleus, the fibers come out. This is the red nucleus. It will cross over this fiber from the dentate, cross over to the red nucleus, and from the red nucleus it will go to the thalamus, and from thalamus it can go to the cerebra, the cortex cerebra. Okay, these fibers are for coordination. For example, this cerebellum wants to tell the cerebra, the cerebral cortex, that okay, this is my opinion, this is the thing you must do, and they have relation to each other. So dentate, the fibers come out to the red nucleus of the opposite part, then to the thalamus, and then to the cortex. Or it will come from dentate and just cross section to the opposite part of the thalamus, or opposite thalamus, not, for example, if it is right to the left, okay, or if it is left to the right. So from dentate to the opposite thalamus, and then to the cerebra. So dentothalamic pathway, or dentorubrosalmic pathway, or dentorubrosalmic pathway, or rubrosalmic pathway, or okay, even from rubrosalmic pathway. And this red nucleus has itself fibers to go down. It means that it has received information from dentate, and those changes which I told you, which name is sharpening, neural sharpening, happened in the cortex of the cerebellum. And now, after coordination, after neural sharpening, the information is coming out from dentate to the red nucleus, from red nucleus to the thalamus, from thalamus to the cortex. Or from dentate to thalamus and then to here, or from dentate to here to red nucleus, and from red nucleus to down, rubrospinal pathway. But as you see, the cross section happens. It means it has information and it wants to just put it in action somewhere. So we have dentothalamic pathway, dentorubroophthalmic pathway, rubrospinal pathway, rubrospinal pathway, and cerebellovestibular pathway. What is this cerebellovestibular? Look at this Purkinje fiber. We are talking about superior cerebellar peduncle. So we are talking about this, everything which goes inside and comes outside. So this is Purkinje fiber. The axon of Purkinje fiber comes down to the vestibular nucleus, and this is called cerebellovestibular pathway. That's it. So these were the efferent fibers. But what about afferent? One of them is ventral spinocerebellar from L to L3 below. Ventral spinocerebellar. It means that it will receive information from the spinal cord, but what part of the spinal cord? From L to L3 below. It receives information. This is afferent. It means it will come to the superior cerebellar peduncle. It means that sensory information from the spinal cord. What part of the spinal cord? The ventral portion of the spinal cord. The sensory informations, the mossy fibers, which I have told in the previous video. We had climbing fibers and also mossy fibers. The cerebellum has two different afferent fibers, the mossy and also the climbing fibers. For the superior cervical, for the superior cerebellar peduncle, we have the mossy fibers. It means every kind of information that doesn't go to the inferior olive will come to the superior cerebellar peduncle. But if it goes to the inferior olive, it will go to the inferior cerebellar peduncle. So the sensory information will come to the ventral part of the spinal cord and then to the cerebellum. And what is this information? From L to L3 below. From L to L3 below, this sensory information, which is called mossy fiber, will come inside, and this is afferent. Another afferent we have rostral cerebellar tract, which is from the cervical portion. Still it is mossy fiber, but from cervical portion. And it will come to the superior cerebellar peduncle. And also tectocerebellar. This is so interesting, okay? Look at here. For the tectum, we have a superior colliculus and also inferior colliculus. It means the information, the sensory information related to the vision, or the sensory information relating to the hearing, for the ear. The superior colliculus, which is for vision, and inferior colliculus, which is for hearing. This sensory information will come into the cerebellum, and this is an afferent. Look how I have drawn it. This is afferent. It means it comes to the superior cerebellar peduncle and it finished. So these are efferent, these are afferent. The dentothalamic pathway, dentorubroophthalmic pathway, rubrospinal. Rubrospinal is going down. This is the information which has come to the red nucleus from the cerebellum to the opposite part of the red nucleus can come down. So it is called rubrospinal. And it's also cerebellovestibular. Cerebellovestibular from the Purkinje to the vestibular. And also afferent ventral spinocerebellar from L to L3 below, and also from cervical we call it rostral cerebellar tract, and also tectocerebellum, or from the superior colliculus, inferior colliculus to the cerebellum, and it finished. So superior cerebellar peduncle, the efferent finished. Now we want to talk about the middle cerebellar peduncle, and it's so easy. Easy peasy. So it's so easy. What I mean, it has only one afferent fiber. I mean that I am going to tell you only one afferent important fiber. Afferent means it comes inside. But what is it called? Cortico-pontocerebellar fiber. Cortico-pontine nucleus. This is the pons. This is pons. These are pontine nucleus. These are pontine nucleus. So cortico-pontine cerebellar fibers. Cortico-pontine cerebellar fibers. But what happened? From the cortex, there are some informations, fibers, which they have action potential, of course. They are talking to each other by neurotransmitter and action potential. So, some fibers from cortex, it will come to the basal ganglia. I will talk about basal ganglia in the next videos, but know that there are some nucleuses in here. They are called basal ganglia, and they are related to the motor decisions. So some information from the cortex will come to the basal ganglia and also will come to the pontine nucleus. From pontine nucleus, it will go to the opposite side and then to the cerebellum. So from, for example, right right part of the cortex, it will come to the left cerebellum. From the left part of the cortex, it will come to the right cerebellum. So it has the cross section from the cortex to the basal ganglia. It has cross section. It will go to the opposite part of the cerebellum, and it is called cortico-pontine cerebellar fibers. And it finished. Let's talk about the next, inferior cerebellar peduncle. This is inferior cerebellar peduncle, and it's so interesting. Let's start it. First, I will talk about the afferent fiber, okay? So here we have dorsal spinocerebellar tract. What I mean? Dorsal spinocerebellar tract. In here, I talked about ventral spinocerebellar tract, which goes into the ventral part of the spinal cord. But there are some fibers which goes to the posterior or dorsal part of the spinal cord. And then they will come to the cerebellum. So, for example, there are some sensory informations in here. What I'm talking about? I'm talking about the climbing fibers. Okay, so look, this is so important. So important. I'm going to write it with red. Look, the ventral spinocerebellar tract, which comes from L2, L3 below, is the massive fiber. It will go to the superior cerebellar peduncle. Superior cerebellar peduncle. Okay? The dorsal spinocerebellar tract from C8 till L2, L3. This was from L2, L3 below, superior. The inferior, C8, cervical number 8, and L2, L3 is the dorsal spinocerebellar tract. It has sensory information. It understands sensory information. This is dorsal root ganglion, which is originated from the neural crest, as I have told you. So in here, the sensory information comes to the dorsal gray horn, then it has cross section, then it goes to the inferior olives, Then from inferior olives, it has a cross section, then it goes to the same side, The afferent fibers always will go to the same side of the cerebellum. The sensory ones, which cerebellum wants to receive, will go to the same side. They are ipsilateral. So, ipsilateral, yes. So, okay. So this comes in here, cross section, inferior olives, cross section to the same side of the cerebellum. This is called dorsal spinocerebellar tract. From what part? From C8 till L2, L3. L2, L3 below was something else, massive fiber. This is climbing fiber. Any sensory information which goes to the inferior olives is a climbing fiber which goes to the cerebellum too. And also cunocerebellar tract. Cunocerebellar tract is upper than C8. We are talking about C8 till L2, L3. Here is upper than C8. So cunocerebellar tract. What I mean, sensory informations which are received upper than C8. Vestibulocerebellar tract. What I mean, vestibulocerebellar. It means from the vestibular nucleus to the cerebellar. Yes, there is a connection. On the other hand, from the vestibular nucleus to the 6, 4, and 3 for the movement and coordination of the eye movement. We have, for example, let me tell you like this, that for the coordination of the eye and also the hearing, for example, someone calls your name and you just come back and look at it. Or you just follow one person by your eyes, okay? You follow someone by your eyes. So these are the coordinations which happen between your cerebellum and also these nucleuses. And what are these nucleuses? Number 3, number 4, number 6. Number 3 in the midbrain, 4 in the pons nearly, and 6 also. And vestibular nucleus in here. So what I wanted to tell there are some fibers from the vestibular cerebellar to the cerebellum, from which comes from inner ear. For example, information about balance and also information about equilibrium. From the inner ear will come to the vestibulum. From vestibulum will go in here to the same side. This is afferent, and it goes to the same side. Vestibulocerebellar and reticulocerebellar. Reticular nucleus in here located. It is so long. Reticular nucleus. From reticular nucleus. Reticular nucleus is somehow so important because any kind of information which is sensory and wants to go up, it has a fiber to the reticular nucleus too. And that is why reticular nucleus is formed. So it contains a lot of sensory information from the reticular nucleus to the cerebellum, inferior, cerebellar, peduncle. And finally, the efferent fibers, the fibers which come out. They are so easy. Easy peasy. Cerebello-reticular fiber. What I mean? Cerebello-reticular fiber. Not only from the cerebellum not only from the reticular nucleus to the cerebellum, but also from the cerebellum to the reticular nucleus, we have a relation. And also cerebellar vestibula. It means from the cerebellum to the vestibular nucleus, then to the 6, then to 4, then to 3 nucleus. The nucleus, the cranial nerve number 3, cranial nerve number 4, cranial nerve number 6, which is responsible for the eye movement, for example. So from cerebellum to the vestibular equilibrium, to the equilibrium nucleus, to the vestibular nucleus, and then to 6, 4, and 3. So that's it. Anyway, I just wanted to tell you that cerebellum is important for equilibrium, for balance, and also muscle tone. And these are the pathways which cerebellum is these are the pathways which are important, in fact. And cerebellum is mostly using them for having relation with other parts of the brain. So as you see, there are some efferent fibers. The easiest one was this middle, cortico-pontocerebellar. It was efferent. And that's it. This was everything I wanted to talk about cerebellum. So in this video, I finished talking about cerebellum. In the previous videos, I had talked about the anatomy, the functional anatomy, the nucleuses, and also the cortex, the layers of the cerebellum. And in here, I try to talk about the pathways in an easy form, so you understand it very well. Thank you for watching this video. I don't have anything to add, and that's it.